Solving quadratic equations using the quadratic formula is oftentimes one of the most popular methods, although I have to admit I don't really like it very much because it's kind of long. I was going to show you guys how to derive it, and I might make another video for just that, but for now, we're just going to remember it from what we did in class. Solving using the quadratic formula involves looking at a quadratic in standard form. So we need ax squared plus bx plus c. And since we're going to solve it, we're going to find where it equals 0. So using these letters, I'm going to color code them. We're going to fill these into the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All you have to do is plug those numbers into that formula and you will get your two solutions. Here's how you get two solutions. You get two solutions because of that plus or minus right there. If you think back to when we solved using square roots, one of those answers works with the plus and one of those answers works with the minus. So let's look at some applications of using the quadratic formula. To solve using the quadratic formula, we need to have it equal 0, and then we need to figure out what a, b, and c are. In this case, a is 1, b is negative 5, and c is negative 14. So these are the three numbers we will plug into our formula. So the quadratic formula is x equals negative b, which is negative 5, plus or minus the square root of b squared minus 4ac all over 2a. If you have a big fancy calculator that you can do math typing, you could type it in right now and you could get it just simplified to one little number very quickly. But we have the calculators of our minds, so we are going to use that first. X equals negative 5, which is positive 5. Plus or minus the square root of 25 minus 4 times 1 times negative 14. So that's going to be positive 56, all divided by 2. Alright, now we can simplify that square root a little bit more. We have 5 plus or minus the square root of 25 plus 56, which is 81. Divided by 2. Now, a lot of the times, this is where you have to stop with the quadratic formula. But we can actually figure out what the square root of 81 is. The square root of 81 is 9. So this is 5 plus or minus 9 over 2. Now, here's where those two solutions come in. Most quadratics have 2. We have 5 plus 9 divided by 2 is one solution. We have 5 minus 9 divided by 2 is the other solution. 5 plus 9 is 14 divided by 2, so our first solution is x equals 7. 5 minus 9 divided by 2, well 5 minus 9 is negative 4 divided by 2. X equals negative 2 is our second solution. So using the quadratic formula, we got the two x-intercepts of 7 and negative 2. Those are the two solutions for this quadratic. 2x squared minus 7x minus 13 equals 0. We're going to solve this using the quadratic formula. We need equals 0. We've got it. And then we need to know what a, b, and c are. So a is 2, b is negative 7, and c is negative 13. Now we can plug this into our equation, or our quadratic formula. X equals negative b, which is negative 7, plus or minus the square root of b squared minus 4ac all over 2a. Alright, let's start simplifying this guy. X equals negative 7, which is 7, plus or minus, you guys let me forget to write my squared. Plus or minus the square root of 49 minus 4 times 2 times 13. So that's going to be negative 8 times negative 13. Get your calculator out, turn your phone on, do negative 8 times negative 13. You should get positive 104. All divided by 4. Well, now let's add a little bit more. We can fix that square root up a little bit. That's going to be the square root of 49 plus 104. Good thing you have your calculator out. Add those together, we get 153 divided by 4. Are there any perfect squares that go into 153? Anybody? Anybody? Like Bueller? Alright, no, there is actually. 9 goes into 153. So we can simplify even further. We can say this is 7 plus or minus the square root of 9 times 17 over 4, which is 7 plus or minus 3 times the square root of 17 over 4. And that's where we have to stop since we can't take the square root of 17 any further. I want to remind you, this is really two answers. The two answers here are 7 plus 3 times the square root of 17, all divided by 4, and 7 minus 3 times the square root of 17, all divided by 4. If you were doing an application problem, I would want you to find what this decimal approximation was. So I would want you to type these two numbers into your calculator and give me the decimals. In this case, I'm going to leave them here because I don't want to get out a calculator and have to do it. But they would be the same solution. X equals 7 plus 3 times the square root of 18 over 4, and the other x-intercept is x equals 7 minus 3 times the square root of 17 over 4. See why I don't like the quadratic formula as much? It's just so messy. 5x squared equals 80. We do not have equals 0, so I know a lot of you guys would go right to making that equal 0 at this point. But I want to remind you, solving using the quadratic formula is not the only way you know how to solve. You know how to solve using square roots, and you know how to solve using factoring. This problem can actually be solved using all three methods. So I'm going to show you solving with square roots, and I'm going to show you solving with factoring. Solving with square roots, I would just need to divide both sides by 5. So I would get x squared equals 80 divided by 5, which is 16. Then we would need to take the square root of both sides, so we get x equals plus or minus 4. And we're done. So the quadratic formula works always, but it is not always the fastest method. In fact, let's factor this thing too. To factor, you do have to have equals 0. So I'm going to have 5x squared minus 80 equals 0. Now, 5x squared and 80 actually have a GCF. They have 5 in common. So this is the same as saying 5 times x squared minus 16. And x squared minus 16, that's one of our special cases. You can factor this using normal trinomial rules, what multiplies to be negative 16 and adds to be 0. Or you can notice that this is a difference of squares. This is the same as saying 5 times x plus 4 times x minus 4. Well, now solve by factoring. It says you set each of your factors equal to 0. So you end up with x equals plus or minus 4 again. What's kind of cool is that if I were to do this with the quadratic formula, I would get the exact same answer. It's just that that's going to take a long time. We have our solutions, so we're going to move on to another one that has to be done with the quadratic formula. When we have x squared plus 3x plus 4, it kind of looks like one that we could factor. But if we were trying to factor it, we'd be looking for numbers that multiply to be 4 and add to be 3, and I can't really think of any. So I'm going to solve this one using the quadratic formula. I already have equals 0, so now I need A, which is 1, B, which is 3, and C, which is 4. When we plug those values in, we're going to get x equals negative b, which is negative 3, plus or minus the square root of b squared minus 4ac all over 2a. Now we can simplify this a little bit. X equals negative 3 plus or minus the square root of 9 minus 16 over 2. So x equals negative 3 plus or minus the square root of negative 7 divided by 2. The square root of negative 7. That's an imaginary number. So we can simplify this a little bit further. We're not going to be able to get too much farther, but we can at least pull out the I. We can say that x equals negative 3 plus or minus I times the square root of 7 over 2. And that's where we have to stop, since we can't find the square root of 7, and that would be our final solution. But remember, this is actually two solutions. These are the solutions, negative 3 plus I times the square root of 7 divided by 2, and negative 3 minus I times the square root of 7 divided by 2. So this parabola has no real x-intercepts. It just has these two complex solutions. So that's solving using the quadratic formula. I'm not going to do tons more because it really is just a matter of plugging those values in. To get good at it, you just need to practice it a lot, as long as you know what the quadratic formula is. When you use the quadratic formula, you do have to make sure you have equals 0 and that you have identified A, B, and C correctly so that you plug those into your formula in the right places.